Hello, my name is Edwin Munyao. I'm the product marketing manager by Infineon for high-set switches for automotive. Today I'll be talking about our new generation technology products called the PROFET Plus 2. With me today is Andreas Mangler from Rutronik, and is in charge of strategic marketing at their office in Ispringen in Germany.
The new TS-DSO 14 package is quite small. So the smaller footprint and the smaller pin pitch means also a smaller power pad at the bottom of the package. So what does that mean for my thermal management on my PCB regarding the PCB layout, for passive cooling especially?
This is a very good question. One of the things we targeted with our new devices was miniaturization, which meant making the package smaller. Previously, we had the DSO 14 package, which is a body size 14 package, and with the new device, we have the TS-DSO 14, which is the body size 8 package. How we address that to make sure that the thermal capacity or thermal budget on your application remains the same is that we address the shrinking of the devices, so the silicon is much smaller, and also we address the current consumption of the device. The current consumption is roughly 50% lower than what was before. Additionally, we have faster switching without impacting EMC, and with this we have less conductive losses when the device is running. So in a nutshell, we come from this big PCB for a body control module to such a small body control module, and you see the shrink is exactly matching the question you're asking me.
The current sense accuracy was less than 5% of the new PROFET Plus 2 family means also further improvement versus the old PROFET Plus family with less than roughly, I think, 8%. As you know, inrush currents could be extremely high, like from halogen bulbs, for example, or other lights. So what are the benefits from my applications, especially with that improved accuracy?
This improved accuracy is a very interesting. We targeted very specifically with this new technology, and the first thing we do is that we were asked actually to go much lower than 5%. 5% is already benchmark in the market. With this current sense accuracy, we have many customers using it in the market to respond to reducing the wire harness. Reducing the wire harness means cost. You can reduce the number of cables or the length of cables in the car, and again, which is cost saving to you. And if you can do this again, you can really look at the market in a different way and detect loads when they're on or off with this very accurate current sense in the application.
With the two high side channels and two additional discrete power MOSFETs for the low side channel, I can also easily design a full bridge motor control unit. What is the maximum PWM frequency for this full bridge configuration?
Good question. Yes, you can build a full bridge solution with our PROFET Plus 2 devices, and with a passive slew rate of around 10 volt per microsecond, we can recommend a PWM frequency of roughly around 20 to 25 kilohertz.
And do you have some recommendation regarding the definition of the dead time to minimize the losses?
Based on our assessment of the devices, we recommend 2 times the T-off time in the device. Our current T-off time is roughly 110 microseconds, so double of that is around 220 microseconds as dead time.